Okay, so welcome back to my statistics class. So today we're going to talk about the measures of central tendencies. So first of all, let's talk about what is median. So the median value of a set of data is the middle value, and it divides the data into two equal halves. So basically, median is the value in the list of order form from the smallest one to the largest one. So your first step is always trying to reorder the data set from the smallest to the largest and find the middle. So this data set already ordered. But if next time you see some scattered data, you need to reorder it by yourself. So if it's an odd number of value, look, we totally have 1, 2, 3, 4, 5 data. So what you do is you find the middle one, the median one. So this data divides the data into t equal half. So 12 is going to be our median. Okay, what about we have even number of values? Look at this data set B. We have totally 6 data. So what you could do is you find the middle two, which is 12 and 15, and find the average of these two, the average of 12 and the 15. This is going to be our median. So in our specific example, the average of 12 and 15 is equals to 12 plus 15 divided by 2, which is 12.3. So that means for dataset B, the median equals to 13.5. Okay, so what's mean? The mean is the average of the data. We calculate by adding all the value and divide it by the number of the value. Okay, so for population mean, we use the simple meal. For a sample mean, we use X bar. Okay, so this symbol may looks really, okay, what's that symbol means? Don't worry about that. That basically means adds up, or the sum of all the data X. Okay, so for example, calculate the mean of these 3 data sets. Okay, so now we use this formula, which is X bar, the sample mean, equals to the sum of all the value adding up and then divided by the number of data. So how many data we have? We have 3 plus 8 plus 12 plus 15 plus 18 plus 20. We add up all the values from this data set and then divide it by the number of the value. So how many number we have? 1, 2, 3, 4, 5, 6. So that means we divided by 6. So this is going to be our mean, which is 76 over 6. Approximately equals to 12.67. Okay, so what about dataset B? Dataset B is the same. We add all of the data together and then divided it by also how many data? 1, 2, 3, 4, 5, 6 divided by 6. So we have what? Approximately, you use a calculator, is 33.5. So you can see for these two data, they're quite similar, right? Except for the 6th data set, the 6th data. From set A, we have a 20. For set B, we have 205. So if we draw a plot dot, you will find out that, hey, data pad set B, maybe it's look like something like this, right? Okay, let's draw it. Such as we have, let's say this is 200, this is 100, and this is 50. So all of the data maybe is around this area. 3, 8, 12, 15, and 18. And then we suddenly have one is 205. So this is what skew left or right. Remember, the tail is determining the skew. So this is skew right. Okay, so where's the, let's look at where is the medium? So the medium is equal to 14.3, which is approximately here. That's going to be our, not medium, sorry, this is our mean, because that's the average. Remember, mean is average. So what will be the medium? So medium going to be what? Again, it's going to be an average of these two data, which is 13.3. So the medium is here. I'm going to use a different color pen. Let's use green. This is going to be our medium. Okay, so now let's compare to dataset A. So dataset A, we have medium is what? This data already sorted from the smallest to the largest. So medium is going to be the same as 13.5. But what about the mean? Well, the mean equals to 12.67, whereas for the dataset B, the mean equals to 14.35. So remember, we learned about what is outlier. So 205 obvious is an outlier. Maybe there's a recording errors occurs when they're recording data. Maybe they meant to say 20.5, but somehow they're recording as 205. But that doesn't matter. This is the outlier. So look how outlier does to the graph, does to the mean and median. So from here, for these two graphs, you can tell. So the outlier doesn't affect the median. However, what about the mean? Well, if the outlier is really large, that means the mean is going to drag in from the median to the right, goes to the bigger number, which is on the right side of the number line. But what if I have extremely small number, which means what? Skew left. What do you think, what does the mean look like? So the mean is going to drag into the left, which is a small number, right? But the medium is going to be unaffected. It's still going to be here. So now let's think about this question. In here, how do mean, median, and the mode related to the shape of the distribution? So think about it. If it's symmetric, that means the mean and the median are going to be really close to each other or even overlap, right? What about skew left? Remember, if you skew left, you have a long tail to the left. That means your median is going to drag in, your mean is going to drag in to the left side. But your median, which is here, is going to be unaffected. So that means if you have a skew left, your mean is going to be smaller than your median. Whereas skew right is, you also have an unaffected median, still close to the center of most of the data set, but mean, which is the average value, is going to drag it to the right. In that case, you will have a median less than mean. Okay, such as this data. Look, example, a box office earning from Hollywood movie. So if we connect these dots together, you will find out this is what? A skewed right shape. Okay, so if it's skew right, we know that the median is going to be untagged. Maybe it's going to be still here, the majority of the data set, or maybe something even more closer to here. But as for mean, the mean is going to drag into the right side. So, oops, sorry. So maybe the mean will end up to be here. So that means what? The median is resistant to the outlier, while the mean is not. Like I say, the median is not going to affect it by the outliers. Okay, so for the fictional exam data set, how do mean and median compare? So, remember our fictional exam data set, which is, we have it earlier. A student got like a 31 and most of student is passing the grade. So we know that the mean is getting affected by the outliers, but mean also bigger because it's skew left. So that means the mean is going to be, the mean is going to be bigger than the median. Oh no, I'm sorry. The mean should be smaller. If you remember our data set, sorry. Because for our fictional exam data, it's going to look like this one. Most of students passing the exam, except for one, got an extremely low grade, which is 31. So that means it's going to be a skew left graph, a skew left shape. So that means our mean is going to drag into the right, whereas the median still remained in the peak, really close to the peak. So that means the median is bigger than the mean. Okay, so there are two different sets of measures for the center spread. For skew distribution, since mean is really easy to effective by the outliers, so when it comes to skew distribution, we want to use median. And then the spread we use interquartile range. We will talk about more about that later in the later classes. For symmetrical distribution, since mean and the median, they're quite similar, we want to use mean to calculate the center, and when it comes to spread, we want to use standard deviation. So that's it for today. In next class, we will talk more about what is mean and standard deviation. Let me know if you have any questions.